Imagine a future so distant, so cold, and so empty that even the last stars have died, black holes have evaporated, and the very fabric of reality is unraveling. What if I told you that right now, as you're watching this video, the universe is racing toward its ultimate end at an unimaginable speed? Every second that passes brings us closer to a cosmic finale so mind-bending that it makes every apocalypse movie look like a children's bedtime story. But here's the twist that'll keep you up at night. We actually know how this story ends, and it's both terrifying and absolutely fascinating. I'm about to take you on a journey through time itself, billions upon billions of years into the future, where we'll witness the death of stars, the evaporation of black holes, and the final breath of reality as we know it. But don't worry, this isn't just doom and gloom. Understanding the universe's ultimate fate reveals some of the most beautiful and profound truths about existence itself. Now, before we dive into this cosmic countdown, let me blow your mind with something incredible. The universe isn't just expanding, it's accelerating its expansion. Imagine blowing up a balloon, but instead of your breath running out, someone keeps pumping more and more air into it, faster and faster. That's what's happening to space itself right now, and it's the key to understanding how everything ends. This discovery, made just a few decades ago, completely revolutionized our understanding of cosmic destiny. Scientists expected gravity to eventually slow down the expansion and maybe even reverse it, causing everything to collapse back together in a big crunch. Instead, they found something called dark energy, a mysterious force that makes up about 70% of the universe and is driving everything apart at an ever-increasing rate. But let's start our countdown with what's happening right now and work our way toward the ultimate finale. Currently, we're living in what cosmologists call the Stelliferous Era, the age of stars. This is actually a pretty special time to be alive, cosmically speaking. Stars are still forming, galaxies are still colliding and creating spectacular light shows, and there's enough energy and matter around to sustain complex structures like planets, life, and even consciousness. However, this golden age of the universe is already showing signs of decline. Star formation peaked billions of years ago and has been steadily decreasing ever since. The universe is getting older, colder, and lonelier with each passing moment. But we've still got plenty of time left in this era. We're talking about timescales that make the entire history of Earth seem like a single heartbeat. Let's fast forward to about 1 trillion years from now. By this point, the accelerating expansion of the universe will have carried most galaxies so far away from each other that they'll disappear beyond each other's cosmic horizons. Any intelligent beings living in our galaxy at that time would look out into space and see nothing but darkness beyond their own stellar neighborhood. They'd have no evidence that other galaxies ever existed, fundamentally changing their understanding of the universe's nature and history. This isolation isn't just about losing the view, it's about losing access to the energy and matter contained in those distant galaxies. As cosmic expansion accelerates, the universe becomes increasingly sparse and cold. The cosmic microwave background radiation, which currently fills all of space with a faint afterglow from the Big Bang, will be stretched to such long wavelengths that it becomes essentially undetectable. But even within our own galaxy, dramatic changes are taking place. The smallest, most efficient stars, the red dwarfs, will continue burning for trillions of years, far longer than more massive stars like our Sun. These tiny stellar furnaces are so efficient at converting hydrogen to helium that they can maintain nuclear fusion for time frames that dwarf the current age of the universe by factors of thousands. Yet even these marathon runners of the stellar world must eventually exhaust their fuel. As we push forward to about 100 trillion years from now, we enter what's known as the Degenerate Era. This is when the last ordinary stars finally burn out, leaving behind a universe populated primarily by stellar remnants, white dwarfs, neutron stars, and black holes. White dwarfs are incredibly dense objects, roughly the size of Earth but containing as much mass as our Sun. They're essentially cosmic embers, slowly cooling over unimaginable timescales. These stellar corpses will continue to glow faintly for quadrillions of years, gradually fading from white to red to infrared, and eventually becoming cold, dark objects drifting through space. During this era, the universe becomes a much stranger place. With no new stars forming, the primary source of energy comes from incredibly rare and exotic processes. Sometimes two white dwarfs will collide, briefly rekindling nuclear fusion and creating a spectacular supernova explosion in an otherwise dark cosmos. Occasionally, matter will fall into black holes, releasing tremendous amounts of energy as it spirals toward the event horizon. But here's where things get really weird. In a universe this old and sparse, even the most unlikely events become inevitable given enough time. Dead stars can actually be revived through quantum tunneling, a process so improbable that it would typically take longer than the current age of the universe for it to happen even once. But with quadrillions of years to work with, even these quantum miracles become routine occurrences. Brown dwarfs, which are failed stars that never quite achieved nuclear fusion, might finally ignite after eons of gradual gravitational contraction. Planets can be captured by passing stars and warmed enough to potentially harbor life. The universe becomes a place where patience is literally everything, and the impossible becomes merely delayed. As we venture deeper into the future, approaching 10 to the 34 years from now, we encounter one of the most speculative but fascinating possibilities: proton decay. If certain theories of particle physics are correct, even protons, the building blocks of atomic nuclei, are not eternal. They would gradually decay into lighter particles over unimaginably long timescales. This potential process would fundamentally alter the nature of matter itself. Planets, asteroids, and the cold remnants of stars would gradually dissolve atom by atom. Any complex structures that managed to survive until this point would find themselves battling against the very fabric of matter slowly coming apart at the seams. But even if protons don't decay, the universe faces another inexorable process: the gradual evaporation of black holes through Hawking radiation. Stephen Hawking discovered that black holes aren't perfectly black, but actually emit radiation due to quantum effects near their event horizons. The smaller the black hole, the faster it evaporates, while the most massive black holes will persist for timeframes so long that standard notation breaks down. We're talking about 10 to the 100 years for the most massive black holes to completely evaporate. To put this in perspective, if the current age of the universe were compressed into a single second, this time frame would still be longer than the age of the universe by factors that require exponential notation just to write down. During the black hole era, these gravitational giants become the dominant features of the cosmos. They slowly consume any remaining matter while simultaneously losing mass through Hawking radiation. The universe enters a delicate balance between accretion and evaporation, with black holes serving as the final repositories of organized energy in an increasingly chaotic cosmos. As the largest black holes finally evaporate, they don't go quietly. In their final moments, they release tremendous bursts of energy, briefly illuminating the otherwise cold and empty universe with brilliant flashes of light and particles. These explosions represent the last hurrahs of stellar mass objects, the final conversion of organized matter into pure energy and elementary particles. What comes after the last black hole evaporates is perhaps the most profound and unsettling phase of cosmic evolution, the heat-death era. At this point, the universe has reached maximum entropy, meaning energy is distributed as evenly as possible throughout space. No organized structures can exist because there are no energy gradients to drive the complex processes that create order from chaos. This doesn't mean the universe becomes completely static. Quantum fluctuations continue to create temporary patterns in the vacuum, but these are fleeting and random. Occasionally, purely by chance, particles might arrange themselves into more complex configurations, but these would be isolated islands of temporary organization in an ocean of fundamental randomness. Some physicists speculate about even more exotic possibilities in this far future. Vacuum decay could potentially trigger a phase transition that fundamentally alters the properties of space itself. False vacuum decay scenarios suggest that what we consider empty space might not be in its lowest energy state, and a quantum tunnel to true vacuum could propagate throughout the universe at the speed of light, essentially rewriting the laws of physics as it spreads. Another mind-bending possibility involves quantum tunneling on macroscopic scales. Given enough time, even large objects could spontaneously tunnel through energy barriers that would normally be insurmountable. This means that in a truly eternal universe, every possible configuration of matter might eventually occur through pure chance, including perfect copies of our current cosmic epoch. The concept of Poincare recurrence suggests that in a finite system, any initial configuration will eventually repeat itself given sufficient time. Applied to cosmology, this implies that our entire observable universe, down to every quantum detail, might spontaneously recreate itself through random fluctuations. Though the timescales involved are so vast they make our previous cosmic ages seem infinitesimal. Yet perhaps the most optimistic scenario involves the possibility that intelligence and consciousness might find ways to persist even in these extreme future conditions. Advanced civilizations might learn to harvest energy from black hole evaporation, manipulate quantum vacuum fluctuations, or even engineer new universes through controlled vacuum decay processes. These speculative future beings might exist as pure information patterns distributed across vast networks that operate on energy scales and time scales completely alien to biological life. They could potentially outlast individual universes by transferring themselves to newly created cosmic realms, achieving a form of practical immortality that transcends the apparent heat-death of any single universe. But even these optimistic scenarios face ultimate limits. The accelerating expansion of space itself creates fundamental barriers to information processing and communication across cosmic distances. Eventually, even the most advanced civilizations would become isolated in their own shrinking bubbles of causally connected space. The final chapters of this cosmic story remain deeply uncertain because they push against the very limits of our understanding of physics. Questions about the nature of time, consciousness, and existence itself become paramount when dealing with such ultimate scenarios. Does time have meaning in a universe that has reached maximum entropy? Can consciousness exist without the information processing that requires energy gradients? What makes this cosmic countdown both fascinating and humbling is that it forces us to confront the ultimate questions of existence while highlighting just how special our current moment truly is. We exist during a brief flicker in cosmic time when the universe is complex enough to support life, consciousness, and the ability to contemplate its own fate. This journey through deep time reveals that our universe is not just expanding and cooling, but embarking on an epic adventure towards states of existence so alien to our current experience that they challenge our most fundamental assumptions about reality. Every moment we experience, every thought we think, and every discovery we make occurs against the backdrop of this ultimate cosmic narrative. If you're finding this journey through cosmic time as mind-bending as I am, consider hitting that subscribe button to join our community of universe explorers. The universe's final countdown has already begun, and we're part of the story. If you're ready for more cosmic adventures, make sure to subscribe for more incredible science and space content. And don't go anywhere. Another amazing video is waiting for you right here.